right, here we go. Here's your measure of central tendency, which you should have started to take notes on. So the mean, if you put longer definitions because you don't know the definition, put whatever you needed to. But the mean is just your average. And then the median is your middle number. Okay, so these are notes that you should already have completed. The key thing here is we have two different means. We have this one here and this one here. So this is a mu. We call that a mu. Okay, it's a Greek letter for M. So mu, it's almost like a U, but it's, we call it a mu. So mu is mean. Okay, X bar, which is this one here, that is also the mean. You can see that this right here, that is your summation symbol. All right, we dealt with that last year in Algebra 2. That's your summation, okay, summation of the x's. All it means you add up all the x's together, okay? So notice this is a capital N. This one is a lowercase n. That's the difference between the two formulas. But it's essentially the same thing. All the lower or the uppercase and the mu deal with a population. So we talk about a population versus a sample. Okay, so these are the formulas. Now these formulas are unchanged, but there's going to be formulas that will be different. It's depending on whether you have a population or a sample. Okay. Okay, so mu goes with population. So when we're talking about a population mean, we're talking about the mu. Okay, calculator buttons, we'll go over what to put in for the calculator. And so that way you can get the average and the median. The only thing you won't be able to get is the mode from the calculator. You got to figure that out. But everything else will be pretty much self-explanatory. Okay, so the mean is sensitive to the influence of a few extreme observations. In other words, it is not resistant to the measure of center. The median is more resistant to the measure of center. Okay, so I'll show you what that means when I get down to these numbers. Get rid of this first. Okay. To help figure out which is better, think mean is average and median is typical. And mode is the most. Mo. Mode occurs the most often. All right, so I have some numbers here just to help you explain what's going on. Okay, so what I have, 14, 15, 16, 16, 17, 15, 14. So the first thing that you'd like to do is you'd like to put them in order. And we'll see the calculator buttons on how to put those in order. So there's only a few of them. We have 14. I got it. I got another 14 over here. I have a 15, another 15. I have a 16, 16, 17. Okay? So make sure you have, what do we have? 2, 4, 6, 7, 2, 4, 6, 7. Make sure that everything's accounted for. Okay? Now, what it says here, it says the mean is sensitive to the influence of a few extreme observations. Okay? So what that means is if I took the average of these 7 numbers, if I was to take the average of those 7 numbers, it would be pretty close, okay, to like 15, 16. Okay, it might be 15.2, 15.25, 15.5, whatever. Okay? If I throw in another number, if I throw in an extreme observation, okay, so let's say I throw in 54, okay, if I throw in 54, now all of a sudden I put these values in your calculator and you're going to see your mean might be 20. All right, so let's take a second. We'll put these in the calculator. All right, so you have your calculator. You go to your table. Okay, so there were 7 values. All right, so I think I had 2 14s. So I have, actually, I'm going to put it in the way they had it. So I had 14. I got to go back and look. what did I have? 14, 15, 16. Oh boy, I'm going to try to remember this. Okay, so I had 14, 15, 16, 17, and then maybe another 16, 15, 14. I think that's what I had. Okay, but that's all right, right? So it's still, I still accounted for both of them. All right, something like that, okay? Now, here's some things that happen, okay? So get those numbers in. You should have 7 numbers, okay? So get those numbers in. Can do. And it's, I got to look around and see where they are. So we have data. I want to go data. I want to check out statistics. Stat calculation, we're going to definitely do that. Might be under actions. I'm looking for sort. You guys remember where sort is? There it is, 6. Okay, so it's under actions. We do sort. Okay, so 6 for sort. And you can see you sort by ascending, or we can do, get out of there. We can also do descending. Okay, so either ascending or descending order. And what that is going to help you do, that is going to help you put everything in order. So if I sort A, okay, because I'm in column A, by ascending, there's my OK, and look, now everything is in order. Okay, so I have the 14s group, the 15s group, the 16s, and the 17. Okay, just like I had. Okay, so sorting it helps you find out if you have a mode. It puts everything in order. And that way, this also helps you find the lowest and the highest if you're looking for the range. Okay, and you don't make any errors and forget a value. Now, the next thing that you want to do is you want to go to menu again, stat calculation, one variable stat. So it's 413. Okay, so menu 413, and you have your X list is A, and you just keep scrolling down. There's no Y list. Frequency is just 1. You never store the result in the same column that you are working with. So then go down to OK, enter. Required field is empty. What does that mean? I don't need a Y list, though. Oh, I did. And you know what I did? I hit linear regression by accident. So I don't know why that happened. So menu 4, 1, 1, 411. Information, number of list 1. Okay, hit 3 by accident. 413. There you go. X list, frequency list, category list. So it's 411. 413 gives you the line and your R value. Okay, store first result column in B. Okay, and there you go. All right, see that right there? So this is your one variable stats. Now, what the calculator will always give you, I really need to, I got to go to my desktop. So what the calculator will give you, if you look at your data that came out, is you see how number 2, you see how they give you an X bar? That's what they give you. They give you an X bar. So they just always treat it as a sample. So there's my X bar, 15.285. Okay, and then what's up? What do you need? Okay, so now the summation of X, see that? We need summation of X. We'll need the summation of X squared. Now these two are key. See this one right here? See this SX? And this is the lowercase mu x. You see those two guys? Those are called standard deviations. Okay? This is the standard deviation, a sample. We're going to use the long formula to find standard deviation, but you can always check in your calculator to make sure that you have it correct. Okay? So here we are with the mean. Oh, the only thing, look, it gives you a 5-number summary down here. Okay? N, which is the number in there. So then you have your 5-number, your min, your Q1, your median, your Q3, and your max. Here's your median right here of 15. Right? There's your median. Okay? So we have to find the mean, the median, and the mode. Now, listen, I'm not going to tell you again with that phone. Then you wonder why you're behind. Sorry to bother you, everyone who's listening to this. Okay? So look at that. There's your median, all right, at 15. Okay? So I am going to add a number. So right here, what did I have? 54? So watch what happens when I add 54. It's like a little magic trick. Okay? So now, see what happens with the X bar? See right there how it's 20.125? Okay? But look at the median. See how the median only changed to 15.5? Okay, see the difference there? So that's why in the notes, we say the mean is sensitive to the influence of a few extreme observations. In other words, it is not a resistance measure of center. Okay, and the median is more resistant to the measure of center. So that means if I have one, what we call an outlier, okay, then that really affects the mean, but not necessarily the median. Okay, does that make sense? So that's how things can change. Okay, now, when is there no mode? The next part of the notes. When everything shows up once, okay, or more than two of them, okay, but that we don't want that. If there's no mode, it just shows up more than two is the next one. Okay, everything shows up once, there's no mode. Okay, what if two entries have the same frequency? We call that or multimodal. Okay, and if you look at this one here, we have two 14s, two 15s, two 16s. Those would all be identified as the mode. Okay, so that would be, you could say trimodal if you wanted, or multimodal. Okay, so that's what with the mode. All right, questions on that? Okay, examining distributions. All right, some of these you might have, some of you don't. Like I said, if they're blank, no big deal. So you look for overall pattern and noticeable deviations from the pattern when you're looking at a distribution. The overall pattern can be described by shape, center, and spread. Okay, and that's when you're looking at bar graphs. To describe shape, one mode, aka unimodal, like a unicycle, right? Only one wheel. Okay, or many modes, many peaks, kind of fluctuates. A uniform when all entries are the same. And then we have skewed. Okay, skewed left, skewed right. Okay, so I am looking at some pictures on page 73. Okay, when you look at some pictures on 73. Your uniform would be top left. I'm talking about that in a minute. Okay, so if we're on page 73, your one mode is top left. If we're on page 73. Okay, so one mode, unimodal. It's like your normal bell curve. Okay, it's like your normal bell curve like that. Okay, if you were to fill it in. All right, and that's what stats2 is based upon, a standard normal distribution. Okay, so it's symmetric. Okay, many modes, we're going to see that on the next page. If you turn to page 74 and look at number 11. I can't turn everyone's page. 74 comes after 73, B-Rigs. Very good. Okay, so if you look at number 11, you see how it kind of goes up. Okay, it's like a cityscape, all right? So that is your many modes, your peaks. Okay, so one mode only has one at the top. Okay, and it's symmetric, or you can have many modes. Okay, uniform when all entries are the same, that's your top right on page 73. So your top right is uniform. Everything's the same. Okay, you know what you do there? That's like if you flip or you roll a die, all right, 1 through 6. What's the probability you get a 1? 1 out of 6. What's the probability you get a 2? 1 out of 6. Probability you get a 3? 1 out of 6. Okay, they're all the same. All their probabilities are the same. Okay, now your skewed left, skewed right. Okay, now you look at the bottom left, all right, is your skewed left. Okay, on page 73. So what happens is the tail is to the left. That's a skewed left distribution. Okay, skewed right is the tail goes to the right. Okay, and that's at the bottom of 73. All right, you can have a bell curve or you can have a bar graph. Okay, we will use bell curves. Okay, that's why I showed bell curves up here on the board. Okay, as opposed to drawing all these bar graphs that you see on page 73. Okay, all right, and now here's your important deviation, the outlier. And I think we already talked about the outlier. Remember we talked about taking the age of everyone in this room? Okay, it'd be pretty representative of the students in here, but then you throw my age in. Yeah, the outlier, exactly, you know? So it's like that through 54. I know it's not, okay? So that's an important deviation. You have your outlier. So sometimes when I say, well, you know, I can keep the outlier, I can get rid of it. Okay, it's like saying that somebody who really did poorly on a test or someone who really did well on a test. Okay, well, the most of the class got a 70, but this one kid got 100. You know, most of the class got 80s, and one kid got a 25. Okay, so there's your outlier. Outlier. All right, you said it. All right. Yeah, so determine if something's an outlier. Look for points that are clearly apart from the rest of the data. All right, and you have an entire bar missing. Okay. So these are on page 72. Okay, kind of a little backwards. So you see your formula. Make sure that formula is written. You guys have got to make sure you write formulas exactly as they are written. If you forget parentheses, if you forget anything, it will throw off your result. Okay, so you have to make sure that you have the formulas exactly the way. So it's an x bar, summation of x times f in parentheses, all over n. Okay, what is x? X is a midpoint. What is f? F is the frequency. Okay, so these are some things you might want in your notes. It's right on page 72 at the top. So you stop eating your cookies and let's get some things down. Come on. Formula, it's got to be in there. Okay? Well, we're flying. Okay? So n equals the summation of f. Okay, what does that mean? That's the sum of your frequency. Pieces of data, okay, that you have. Okay, so all that stuff you need at the top of page 72. And then you should have filled in. All right, find the midpoints of each class. There's your x. Lower limit plus upper limit divided by 2. What's the 2? The sum of all the products, the summation of x times f. This is 72 again. Sum of the frequencies, n equals the summation of f. And the mean of a frequency distribution, x bar, is the summation of x times f over n. Okay, so that's all stuff that you should have had completed. Okay. All right, we did that in class yesterday, hopefully. All right, so now what you have is you have this right here. You have your classes and your frequencies. Okay? So I don't know if I have enough room up top, but above it you might want to put your F. Okay? Because F is your frequency. Okay? Now, this is a frequency distribution. What is a frequency distribution? Means that you data values. You see how there's no tallies? You do not know what the exact values are. All you know from, we'll just look at the first number, 6. It's you know that there are 6 pieces of data between 7 and 18. Okay? You could have 1 7, 2 15s, a 16, and 2 18s. You have no idea. Okay? The 10, what does the 10 mean? That there are 10 pieces of data between 19 and 30. Okay, that fall in that class or interval. Okay, that's all you know. All right? So in order to find the mean of the frequency distribution, I also need the midpoint, which is your x. The midpoint is your x. Okay? And remember, the midpoint is the lower limit plus the upper limit divided by 2 that we've already been quizzed on. So I have to take my 7 plus 18, divide it by 2. So go ahead and find the midpoints of all the classes. Okay, so there are your midpoints. All right, now, who could tell me the class width? What's the class width? So each class, 7 through 18, 19 through 30, 31 through 42. Don't yell it out. Figure out the class width. Put it in the bottom left corner of your notes, or the bottom right. I don't care. What is the class width? And I'll tell you if you're right or wrong. Bottom right corner, bottom left corner, somewhere as I come around. Yo. No. What do you think? I don't know where that came from. No, what is that? That's like the range. 7 through, what'd you say, 79? No, class width. Class width. Yeah, okay, good. Good. Somebody already checked, sorry. Okay, so here we go. Class width. Okay? It's how many pieces of data are in each class. You can always do 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? You can always do that until the width is from 100 to like 1500. You're not going to want to do that. That's crazy. Okay? So class width is 12. What is it? It is the difference between any two consecutive lower class limits or any two consecutive upper class limits. Just like when you find the class width, the highest minus the lowest divided by the number of classes, and then you do the lower class limits first, right? So 19 minus 7 is 12. Okay? And then when you have the midpoint, what do the midpoint goes up by? Goes up by 12, which is the class width. Okay? So some little things that you're going to have to know. All right? And I saw some people flipping around their notes. That's fine, because you got your notes. Okay? But you have to make sure you understand it, because this stuff that we've already learned, okay, in 2.1 or even chapter 1 that we talked about is going to be on your test next week. Okay? So there's your midpoint. There's your frequency. Now we need x times f. So the easiest way to do this x times f, is to again go to your calculator, go here, and put in f and put in x. All right, so you should have all these values in, all right, in your cells. Always double check your numbers, because if you make one error, everything's going to be wrong. Okay, so from here, you want to find, you see the column that we have in our notes, x times f? Okay, so instead of doing each individual one like I had to do when I was in college, you guys just go here to C, and you're just going to do A times B, enter, and then just copy those results. Okay, so you should have all those results. Okay, so 75, 245, right? All these. Double check them. Okay, and put them in your notes. That goes in your x times f column, whatever they are. It goes all down here. Okay, that's what you need there. So your formula for your x bar is the summation of x times f all over n, where n equals the summation of f. So that means that we need the summation of this column and the summation of that column. Okay? You do it very easily in your calculator. So the summation of f is column A. So I go to my calculator, and I'm just going here. And I can catalog S. You guys got to pay attention. Catalog S. I usually go to T and go up. Okay, so sum, there's a summation, but I go to sum, enter, catalogs above the division sign. And you put A, sum of A, enter, is 50. That means there's 50 pieces of data. Okay, then I'm going to E, catalog again, the sum is there, enter. Now, I need A times B, which is in column C. Okay, sum of C, enter, 2089. Okay, so those are the sums you need, 2089 and 50. So, in your note packet, yep, I will, 2089 and 50. So then we have 2089 divided by 50. We have to find out what the mean of this frequency distribution is going to be. This is your X bar. So back to your calculator. And I guess you could even do it right here. You could do it up here in F. You can do 2089 divided by 50 decimal, enter, and you have 41.78. Okay, and that is the mean of your frequency distribution. So we used this formula right here, summation of X times F all over N. What's up? You put the 2089 divided by 50? Sum of A, because you don't want that. You put, so what happens too is you got to watch where you are. So my A might be different than your A. My A, see my A right there, is the F's. You would do sum of B. Okay? So my A is the sum of F's. Don't want to do the sum of the midpoints. Okay, that's the sum of the X's. Okay, and then what did I say? What was it, 41? 41.78. So go back to your data. So 41.78, which is right about here, which makes sense. Okay, it's somewhere in the middle of the data. You know, you got 16 numbers below here with the addition of this guy. Okay, so 41.78 is closer to this, so you might have an additional 10. So maybe 26 here and 10, 21, maybe 24 here, somewhere like that. Okay, so that makes sense. All right, if you have something that's greater than 90, that's wrong. Something that's less than 7, that's wrong. Okay, because it's got to be within those values. Okay. Yep. So we'll go over this again.